All right, the purpose of this video is to introduce you to discrete probability distributions. We'll get into continuous probability distributions in a later video, so let's get to it. First of all, discrete variables come from a counting process. It's a quantitative variable that we count. Continuous are quantitative variables that we measure. We talk a lot in probability about a simple event, and I think of a simple event. There are all kinds of complex and sophisticated definitions, and if you want to refer to your textbook to get, one of those, you can get it. But I just like to think of it as something that is a simple occurrence for which we can calculate the probability. So if E is an event, then the probability of E is just given by usually cap E, parentheses E. We usually give events, A, B, C, D, capital letters. And the final bullet, just the complement of an event E, is the probability that the event E does not happen. So it's denoted as E with a little mark up on the right-hand side. So if the probability of something happening is 0.75, then the probability of the complement is just 1 minus 0.75, which is 0.25. Sample space, a lot of times in discrete probability problems, we can create a set that's a collection of all possible outcomes. So an example of this is if we tossed 2 coins, what would be the sample space? Well, the only possible outcomes, tossing 2 coins, would be to get a head, tail, tail, head, or tail. Oh, wow. So an example of an event would be getting a tail in the first toss and a head on the second toss. And this is not a simple event. A simple event would be what is the probability maybe of getting a tail on the first toss. Once we bring into a tail on the first toss and a head on the second toss, we get into something that is not a simple event, but we can still calculate the probability of it. Types of probability, we have priori, empirical, and subjective. Priori is just a probability based on prior knowledge. For example, if you think about a standard deck of cards, we have prior knowledge that there are 52. We have prior knowledge that there are 4 suits, hearts, spades, diamonds, and clubs. And we have prior knowledge that we have aces, kings, and so on and so forth. So if I wanted to, for example, calculate the probability that I select a card at random from a deck, what is the probability that it is a club? Well, I know I have 13 clubs out of 52 total cards, so the probability would be 1/4. Empirical is interesting. It's a calculation of a probability that's based on something that you have observed. For example, if you wanted to maybe give a survey to SSU students and ask them if they have multiple social media accounts, or, well, the example I use here, if they have an iPhone, you could maybe take a sample of maybe 500 people, and maybe you find that 300 have an iPhone and 200 don't. So the probability would be calculated on the collected data, not some prior knowledge. Subjective probability is just something that varies. It's based on different perspectives of people. For example, if you ask me, what's the probability of a student completing my course successfully, I'm going to say very high, probably about 0.8. If you ask another professor, what's the probability of a student successfully completing their class, they would give you a different calculation. So a subjective probability is something that is based on different perspectives, therefore we expect variation. Types of variables, again, discrete variables and continuous. As we'll find out later, continuous variables have these distributions that are smoothed out, and discrete variables have something that reminds us more of a bar chart. So discrete can only assume a countable number of values. If we roll a die twice and we let x be the number of times that a 4 occurs, then x could be either 0, 1, or 2 times. If we toss a coin 5 times and our x is the number of heads, then x could be either 0, 1, 2, 3, 4, or 5. So again, it's just a discrete variable corresponds with a countable number of values. So that should be one of those things that are tattooed to your brain, that discrete corresponds with countable. All right, so once we get a discrete variable, and the illustration that we're using here is interruptions per day in a computer network. First thing I want you to notice is that the probabilities have to add up to 0 to be a legitimate probability distribution. So if you do the math over here, we have what, 0.60, 0.80, 0.90, and plus, so it'd be 1.0. And the probability of having 0 interruptions. Now, I would say this would be an empirical distribution. So someone has probably counted these, has observed these counts, and created a probability distribution. So the probability of having, for example, 5 interruptions is only 0.05. Now, another way to represent this would be graphically. So you would have the count on the horizontal axis, and you would have the probabilities on the vertical axis. And you can see what we've done. I'm going to teach you how to do this on StatCrunch. It actually turns out it's pretty cool. So anyway, the height of the bar just corresponds to the probability. Now, once we get these discrete probability distributions, we want to be able to find the expected value or the mean. And notice something that we get into here. Notice that the mean now takes on a different value. So once we move into lesson number 2 for this this class, once we move into probability, we start thinking of things in terms of a population. And I'm going to explain that in a lot more detail in a video that will be in this lesson. But for now, just again, it's one of those things that you have to put in your notes, you have to make note of, that the mean for a probability distribution is no longer x bar, as we did in lesson number 1. The mean is given as mu. It's a Greek letter, so mu. So to find the expected value of the mean of a probability distribution, discrete probability distribution, we take the x times the probability of the x, and then we add it up. That's all this is saying right here. So my x in this case is 0. My probability is 0.35. So I take x, 0, times the probability 0.35, and I get 0. I do that for the next entry. So I take a 1 times its probability, and I get 0.25. Do it for the next. 2 times the probability, I get 0.4. I do that for all of the values in the discrete probability distribution. And then over here, I add these up. I'll take 0 plus 0.25 plus 0.40 plus 0.30. That's what the summation stands for right here. We're going to add up these values. And when I do that, I get mu equal 1.4. Now, in the next video, I'm going to demonstrate on StatCrunch how you make these calculations using the formula, and then I'm going to show you how to do it, make the calculations using a shortcut, a creative shortcut. We can also calculate the variance and the standard deviation. They're a little bit more in depth. The variance is just the sum of, we take the x minus the mu squared times the probability of x. So let's do that. So again, we take x minus mu, so let's do it. We took the x is 0 minus the mu, which we found to be 1.4 in the previous problem. We square that, and we get 1.96. Take the value minus the mean, square it, we get this. Take the value 2, subtract the mean, square it, we get this. Okay? Now the next thing we have to do is we have to take those values, the 1.96, and multiply times the probability of that. So come back over here and grab the 0.35. So we have the x minus mu squared, which we'll get in this column, times the probability Ultimately, we calculate all these probabilities, we add them up, because that's what the summation says, and we get 2.04. To get the standard deviation, we have to take the square root of 2.04 to get 1.4283. Again, more about that in the next video. So what's to come? What's to come is we are going to study, in this problem, we're going to study only the binomial discrete probability distribution, and then we're going to move into the continuous probability distributions and look at the normal distribution. So a little bit about the binomial distribution. Binomial, as you would expect from the prefix bi, means two. So the first thing we have to consider with the binomial probability distribution is we have a fixed number of observations. We toss a coin 15 times, we collect 10 light bulbs from a warehouse, whatever it is, we fix the number of observations, all right? Number of test questions, we fix it. There's 50, there's 20, whatever it is, we fix it. Now, the next thing, each observation is categorized what I call dichotomously, either this or that, right? It's whether or not the event happened. So if we're tossing a coin, it's binomial because we either get a head or a tail. If we're looking at the status of a light bulb, it's binomial because it's either defective or not defective. If we're looking at employees using all of their sick days, then they either did or they didn't. So anything that falls into a classification where it is either this or that. Okay, let's think about a test question. If it's multiple choice or true false, you either get it right or you get it wrong. If someone checks into an ER with serious medical conditions, they either survive or they don't survive. If you're taking my class, STAT1800, you're either going to succeed or you're not going to succeed. And I typically think succeed is C or higher. All right, so some possible applications to the business world. Again, manufacturing plant labels either defective or acceptable. Firm bids for contracts, they either get it or they don't. Marketing firm puts out a survey. The customer indicates they're either going to buy the product or they are not. And if you have work in HR, you might interview job applicants where the person that you offer the job to either accepts or they do not, they reject it. All right, gang, that's all I got. Take care.